Hi, everybody. Good afternoon and welcome to yet another AIRISE webcast. Today's topic is going to be around AI solution categories. We are going to see how AI can help you, what are the different types of AI that one can use, and what is the main difference between those, and also what is common between such solutions and see some examples of AI solutions in manufacturing. Together with us today, we have our expert on the topic, Pavel Buget from the Czech Technical University in Prague. Pavel, welcome and good afternoon.
Hello, Harry. Good afternoon.
Hi, and good to see you and good to have you here with us today. So let's start discussing a bit about AI and AI solutions in manufacturing. Can you please start by explaining to us a bit what is an AI solution in general and what is common to AI solutions when we discuss them in the context of solving manufacturing problems?
AI solutions are focused on deploying sort of services to companies which are based on machine learning and artificial intelligence. In the context of manufacturing, it's mainly around the data. As you may know, AI usually aims to provide a solution that is based on real scenario, and such a real scenario is described by data. So that AI algorithms learn from the data and give answers based on what they learn.
Mm-hmm. So you repeated the word data a few times. So I assume that the main outtake of that, the central outtake of that, is that when we talk about AI solutions, specifically AI manufacturing, we always talk about data. We need data. We deal with data. So keyword number one is data and data availability. I think that we have different types of AI solutions. We all hear about different types of AI on our daily lives, and more about things like generative AI, large language models, with all the rise of these tools that are commonly available to everyone. Can you orient that a bit more towards manufacturing, and can you give an example of a simple AI solution in manufacturing from what you have already seen and from what you already know?
Mm-hmm. So basic solution, or very simple solution, very simple approach that is really applicable in the manufacturing sector is called support vector machines, abbreviated as SVM. It is quite an old algorithm, but still very efficient and very accurate in many cases. And it classifies data by finding an optimal line, or let's say separation line or plane in multidimensional space that maximizes the distance between between each class of data. And typically these data are or these data mean for example OK and non-OK parts, which are recognized by some image processing algorithms and then classified. So during the training process, which is supervised, the classification is done so that there must be some human intervention that says which data are OK, which data are non-OK or represent OK or non-OK parts. And then during evaluation, when the AI algorithm, the AI solution runs on real data, real process data, so the existing data are assigned to the classes, and by this way, the SVM evaluates the parts accordingly.
So if I get that correctly, this is oriented more or less in problems when you want to separate good products from bad products, good quality from bad quality, essentially putting them on one category or another, which in reality is quite a few of the problems in the manufacturing field.
Definitely, and there are a lot of tasks in manufacturing which are about distinguishing correct or well-produced parts.
You also mentioned a few words that I would like to pick for the sake of the discussion, like training and supervised learning. As you explained in this case, this means that we need to provide data in order for the algorithm to learn what is a good product and separate that from a bad product, I would say. And we need to give examples to that algorithm. So someone needs to teach it, as you would teach an employee, to distinguish, I would say, between good and bad, a good product and a bad product. Someone still needs to do that part of training with the algorithm. Is that right?
Yeah, that is completely correct. This training process is done by operators, by human who are able to recognize the quality, for example. So experienced operators, technological experts focus on the specific production technology and so on.
So the key here is to actually already have the expertise on your side to be able to do that job in the first place, but then obviously you can substitute human quality control operators, I would say, with something that's AI driven. And obviously it's much faster and in most cases, I would guess also much more reliable than a human going over the production. That's a simple application. That's the simple scenario. How about a more complex example of an AI solution where AI gets complex, let's say in the context of manufacturing? Can you give an example of something like that?
Yeah, we can take, for example, reinforcement learning, which is machine learning techniques that mimics the trial and error learning process used by humans to achieve their goals. The algorithm learns from the feedback of each action and self-discovers the best path to achieve the final outcomes. Reinforcement learning is a powerful method to help AI systems achieve very good results, especially in complex and unknown environment. What is very advantageous compared to the previous simple AI solution is that it requires less human interaction when labeling data. Because the algorithm learns by itself. If we focus on the manufacturing sector again, reinforcement learning can, for example, tune the parameters of a manufacturing process for optimal performance in a way that would be difficult to be done by human operators, because the reinforcement learning algorithm is capable to test and evaluate many ways, many parameters very quickly, much more quickly than human operator can.
Sorry, go ahead.
So reinforcement learning is often connected with another machine learning model, which is called deep learning, and it is a multi-layer neural network which resembles the human brain in the way how it processes the input data. It is suitable for efficient processing of unstructured data, which in case of manufacturing can be, for example, multiple unstructured logs of events manually written notes and observation about the events in the production and other issues in manufacturing. Deep learning is often combined with reinforcement learning. And you definitely can imagine many situations when something happens in the production and the operators or the maintenance people must perform some interaction, some change, some setup of the parameters and so on, and then write a note about what was done. But these are exactly the this is exactly the example of unstructured data, unstructured information, which is very hard to process by using simpler AI solutions.
Mm-hmm. That's super interesting, and we see that there is no a single solution fits all. So we see that AI is not really a unified solution. It's rather individual solutions, individual approaches that can suit one type of problem or another, depending on what you are trying to tackle. So, for example, we talked before about quality classification, and there we said that, okay, you can use something that's rather simple, like SVM, as you mentioned. Now we talked about much more complex problems, or optimization problems, where you might have a much better fit of other algorithms, or even going into unstructured data, when again AI might be able to provide a solution, but obviously we need to have a different approach on the algorithm selection, the algorithm deployment itself. You also mentioned that optimization problems can be solved by AI quite efficiently, and I assume that this difference in performance between AI and human intelligence becomes even bigger the more complex problems we have to deal with. So if I have a relatively single optimization problem with a couple of parameters that I can tune, that I can change, and with a relatively simple phenomena, most probably a human operator with enough experience could do that by themselves. Whereas if we have a very complex process with a lot of factors that can be tuned, a lot of parameters that can be tuned, then I assume that deploying an AI algorithm on top of that would render an optimized solution in a much shorter time compared to what a human would take to do that.
Definitely, we can imagine a production line where there are, let's say, for example, some sorting machines based on vibration drums, for example, which are set for different types of parts to be sorted. So the task for such a machine is to take a pile of parts and then deliver one after one to some further processing or to some further packing and so on. And there may be tens or hundreds of parameters for such a sorting machine to be set to deliver the individual parts one after another properly. Experienced operator can do it, let's say, in a few minutes, or let's say 10 minutes, something like this. But the time to train such an operator takes a few months to do it properly with the optimum performance. The AI algorithm can be trained actually all the time based on the feedback. So it's trained at the beginning for some initial set of data, and then it can improve continuously. And the final setup can be done within a few tenths of seconds for each machine with every change. So you can easily see there is very big advantage and very great savings comparing to the human operator and the AI solution.
That's a great example actually of exactly that. So thanks for bringing it up. One more question, one last question, as we are running out of time. I know that we could discuss the topic for days, and there are a lot of things to discuss around AI, and if we wanted to narrow down a bit the solution field, we would need to start discussing about individual challenges. But one of the core things that we have been discussing all this time is data. What do you see as the most difficult aspect around data in manufacturing? What is the main challenge on that?
Definitely, it's the way how to get the data, and moreover, how to get high quality data, because the high quality is crucial for being able to train the AI solution properly, and a properly trained solution can deliver proper and high quality results in the end. So getting the data physically by connecting some data acquisition system and other stuff is one point of view, and the other point of view is to annotate the data. So there's typically a tedious work annotating the data, which is also very important to be done properly. So actually we started with data, saying that AI is around data. We also end with data, saying that getting the proper and high quality data is one of the biggest challenging in applying the AI solutions. And it differs from project to project, from manufacturer to manufacturer, from solution to solution.
Mm-hmm. That's a very worthwhile observation. By the way, if you are keen on learning on data gathering and how you can generate data in your manufacturing environment, we have a webcast that's already uploaded on that exact topic. So, what are the sources of data? What are the prerequisites of applying AI, and where you can find this data? On the other hand, if you're curious to hear more about data security and reliability, we have a follow-up webcast coming up. So tune in at the beginning of December to find out more about that. Pavel, thanks a lot for your time. I think it was really insightful, and I hope it's useful for our attendees. Guys, if you want to learn more, we're always here, and we would be happy to provide support. Feel free to reach out through our website or through our social media, and we would be glad to get in touch with you and discuss your specific problems. Thanks again, and have a nice
Thank you for inviting me, Harry.
Thank you.